Hello, welcome to A-Level Physics and Mathematics class. Have you ever wondered why the pressure is increased when you move deeper and deeper into the pool? In this episode, we are going to break down hydrostatic pressure formula from scratch. We will move step by step from basic definition to the final equation. So before that, could you please like, share, and subscribe at this video? That will help me a lot. So let's proceed uh, with the proof. So let's say this is a kind of pool. Let's say this is a kind of pool, and then there is a kind of a liquid in this pool. Like I said, when you move deeper and deeper, the pressure is increased. Okay, that is what we are going to break down in this episode. So, by the definition of the pressure, or from the definition of pressure, as you know, that pressure is a force per unit area, right? So meaning that pressure is equal to with a force per unit area. This is a basic definition of pressure, right? Now, from this equation, as you can see, this is this pool or the liquid in this pool is in static way. Okay, so in that case, the force you applied is a kind of normal force, meaning that normal force is basically is equal to with the weight, right? So, what I'm trying to say is F is equal to with the weight, okay? And then, which is equal to, normally we can calculate a weight we're using a mass times with the acceleration due to gravity, right? You can set this equation as a equation, let's say 1, okay? Let's say this is an equation 1, okay? Now, from the definition of a density, as you know that density is equal to mass per unit volume, right? Now, from this equation, you will get that the mass of the object is equal to density multiplied with what? With volume of an object. Okay. Now, you can set this equation as a 2. You can say this equation 2. Okay. You can say this on equation 2. Now, also from this rectangular, or from this, yeah, I would say from this rectangular surface, you can understand the area of this surface is equal to, the volume. Let's say a volume is equal to basically length multiplied with width is multiplied with height, right? Now, from this term, you can see that this guy is basically is equal to width area, right? Now, volume is equal to basically area multiplied with h, or height of the given rectangular surface, okay? Now, you can set this an equation 3, okay? You can say this an equation 3. This is basically, there is an n over here, okay? Now, when you come to the basic definition, like I said, pressure is equal to force over area, right? So force is basically is equal to with weight. Weight is equal to with mg, right? So in terms of this force, you can plug, or you can replace this mg over here. So you will get m, or mass time acceleration due to gravity, over area, right? Now, from this equation, or from equation 2, you can plug this density multiplied with volume. You can plug this parameter, or this physical quantity, in terms of mass, okay? Now, when you plug this guy over here, you will get a density multiplied with volume, multiplied with acceleration due to gravity, right? Now, over area, okay? Now, what you can do is, from this equation, which is basically is equal to, as you can see, the volume of an object is equal to area multiplied with height, right? So you can plug this guy over here. Okay, you can plug this guy over here. You will get that density multiplied with volume means area time height time with acceleration due to gravity. Okay, over area. Okay, now you can cancel this guy with this guy. Therefore, the pressure is equal to density multiplied with height multiplied with acceleration due to gravity over. No, that's all basically. Because you don't need to set the area. We did cancel with the area as well. So that is how to drive the hydrostatic pressure formula. So that is all about this episode. I believe you understand how we can drive this equation. So let me know if you have any question in the comment section. I'm happy to reply to you guys. So yeah, that is it. And then one last thing, I just wanted to let you know that if you would like to calculate the total pressure, what you can do is basically total pressure, I would say total pressure or is equal to the atmospheric pressure plus with this guy, okay, which is P naught basically plus density multiplied height multiplied acceleration due to gravity. So this is how you can calculate a total pressure. Also, if you would like, let me know in the comment section. We will discuss about this in the other episode. So yeah, that's all. Like I said, that is all about this session. So yep, that is, like I said, that's all for this session. And then could you please like, share, and then subscribe